Hello and welcome to Datacasts. In today's video we're going to write just one line of code, but it will complete the process we've been working on to read RDF data. Let's get started. You'll recall that in the last video we were ready to start querying RDF, having downloaded and unzipped files from the British National Bibliography. RDF files are strange beasts, but thankfully R has us covered here. There's an entire package dedicated to reading RDF called RDFlib. But the thing is, I'm not going to use that today because the RDF files we're dealing with are very large, and reading them directly with this package will really slow us down. Trust me, I learned this the hard way. So instead, we're going to use Virtuoso, which describes itself as a data virtualization platform. Honestly, I don't entirely know how this works, but what I can guarantee is if we load our RDF files into Virtuoso, it will speed up our development process significantly. You won't be surprised to hear that there's an R package for working with Virtuoso called, that's right, Virtuoso. This particular package gives us access to the benefits of Virtuoso directly within our R code. Okay, so let's start today by installing the Virtuoso package. Install.packages Virtuoso, and there we go. Now, a little tip here. If you're only calling a package once in your code, then you don't have to load it in like we did with the tidyverse using the library function. So down here in the console, I can just type Virtuoso and you see this double colons. This gives us access to all the functions within that particular package, either here in the console or we can actually write this into the R script file itself. Now the Virtuoso function I'm interested in here is called VOS import. And I'm going to call the help file on this by putting a question mark in front. So this function allows us to load RDF files into the Virtuoso platform. And if we scroll down a little bit here in the help file, we can see that it accepts a whole bunch of different files actually. Virtuoso doesn't just read RDF, it reads other ones like XML, for example. But here's the key line. It says any of these can optionally be gzipped with a .gz extension. Now it's actually a good idea to compress our RDF files because otherwise it will take longer to load them into Virtuoso because, as I said, they're really big files. But I hear you say, didn't we just spend an entire video unzipping them? Why, yes we did, but they arrived as .zip files when what Virtuoso wants are .gz files. So we need to take our decompressed RDF files and recompress them into .gz files. To do that, we're going to install another package called r.utils. And this actually has a function that we need called gzip. Okay, back in my code, if you press the up arrow, you can actually cycle back through code that you've already written in the console. If I go up twice, I get back to this install packages with Virtuoso. So here I'm going to do r.utils, and now I have access to the r.utils functions, and as I said earlier, it is the gzip function that we want. You know how I spent all that time in the last video talking about how the walk function is the right function to use because we don't need to return anything? Well, it turns out that we do need to return something because we need to list the RDF files here before gzipping them. So what I'm actually going to do here is modify the last line that we wrote in the previous video. And instead of using walk, we're going to use map_chr, which behaves exactly the same way as walk, except it returns an atomic vector. In a previous video, I described vectors as kind of like lists, but in R, vectors and lists are totally different things. A list is heterogeneous, meaning you can mix different data types such as characters and numbers, whereas a vector is homogeneous, meaning it has to contain elements of the same type. Either logical, integer, double, character, complex, or raw. Those last two, complex and raw, are rarely used, but the other four are probably more familiar. A logical vector contains true or false. Integer and double are basically the same and they're both numbers, whilst character vectors contain strings, which, as we've seen, are contained in double quotes. So you can probably guess that map_chr returns a character vector. Okay, so back over here, let's go into files. Let's go into unzipped. Now you can see that I've actually already gone ahead and deleted the RDF files from unzipped. So this is an empty directory at the moment. So what I'm going to do is re-extract the RDF files But this time around, I'm going to use this modified code. So we're going to use map_chr. So let's just load up the tidyverse so that we have access to those functions. I don't need to worry about these 3 lines where I was downloading files from the British National Bibliography. We've already done all of that. We have our zip files, and you can see if I just go to raw data zipped, I've already got the zipped files. So what I'm interested in now is extracting the RDF files from within these zipped files into the unzipped folder. So I'm going to run these 2 lines of code. In the first line, I'm going to be listing the zip files, and then I'm going to run map_chr. So let's see what happens. Okay, so over here we can see that we have the RDF files in the unzipped folder. So that's doing exactly the same thing that it did before. But down in the console, we can see that this function is returning this character vector that consists of 3 elements, and these elements are the file paths to the RDF files. Why is this useful? Well, you might recall from our earlier video how we took advantage of tidyverse's piping ability to feed the output of one function into another. That's what we're going to do here. We'll pipe this character vector into map_chr again. Why map_chr and not straight into gzip? Because ultimately that's what we're aiming for here, is to feed these into the gzip function to recompress them. Well, gzip only expects a single file to compress, whereas we have several files. So just like we did when we stepped through the process of decompressing the zip files, we now have to step through the process of recompressing them. So let's put our pipe in. Remember, we can do this using Command Shift and M on a Mac. And then on the next line, let's write out the map_chr function again. We know the first argument is the character vector we've piped in from the previous line. So next up, we want to include our desired function. You may recall earlier I said that if we're only using a package once, then we can just call it with double colons. So that's how I'll pass the gzip function here, using r.utils and then the double colon. You can see now that RStudio is pulling up all of the functions in the r.utils package, and we know that the one that we want is gzip. Finally, I'm going to pass another argument in here called ext, and that is going to be equal to gz. And this just tells gzip which file extension to use. That's important because we saw in Virtuoso's VOS_import function that it expects this file extension if we're importing compressed RDF files. So we have a bit of a flow going. We create a variable which we pass into this function, we pipe the output into the same function again, but doing something slightly different. Now if we quickly review the help file for the gzip function here, so if I just do a question mark in front, and come over here and look into the help file. If we scroll down and look at the arguments, we notice that it has an argument called remove. It says, if true, the input file is removed afterwards, otherwise not. Now if I scroll up and look at this kind of generic decompress file method, and the default for remove is set to true, meaning that when I run gzip, it will recompress the RDF files and then remove the RDF files. This is actually quite useful because these RDF files are quite large. If I come into files and have a look, we can see that there's sort of 12 megabytes, 22 megabytes, 10 megabytes. These are quite big files. And if I'm going to download more and more of these files, they'll take up quite a lot of space. And there's actually no point keeping them because we have the original zip files, and then eventually we will have a gzipped version of these RDF files. So if I did want to get the actual .rdf file again, then I could do from extracting it out of either zip or gzip, but I don't need the extracted RDF. I can get rid of that. However, this has consequences for our directory structure. If the recompressed files are stored in the same directory as the RDF files, and that's what's going to happen here, when I gzip these RDF files, the .rdf.gz files will appear in here, in unzipped. So that folder name unzipped wouldn't make sense anymore because we'll have a mix of extracted RDF files and compressed .rdf.gz files. Instead, we can actually keep everything in the zipped folder because ultimately all of the files we're keeping are zipped in some way. Okay, so back in our code, let's tweak the first map_chr function so that it stores the RDF files in zipped rather than unzipped. So we can do that just by changing this to raw data/zipped. That's now where the RDF files are going to be stored. We know this is okay because in the very next step, we will recompress those files and then delete the originals. So ultimately zipped will only contain zipped files. I can then delete the unzipped folder. So over here, I'm going to select unzipped and I'm going to delete it. I'm going to say yes. So I've deleted the zipped folder with the RDF files inside it. And now we're good to go. So the first thing I'm going to do is just clear my console here. This is good practice as you're developing, by the way. You use this function called remove and then list equals ls. Essentially what this will do is if I hit enter, and if I look over here in my environment, you can see that the zipped underscore files variable has disappeared. It basically resets everything. So tidyverse is no longer loaded. My variables have disappeared. I'm kind of starting from scratch, which is what I want here. Because if I've changed what is stored within a particular variable in my code, but I still have that variable saved in its original condition, then that might cause problems. So I want to make sure that my environment is empty by using this little line of code here to clear that environment. So what I'm going to do now is just load up the tidyverse again. And then I'm going to select these 3 lines. As before, I can ignore these lines because I don't need to download the zip files because here they are unzipped. All I'm interested in now is recompressing these. So if I run this code, you can see that what I end up with in this folder is I still have the 3 zip files, but I now have these .rdf, .gz files as well. And down in the console, it lists the paths to these 3 files that we've just created, which I can then feed into Virtuoso to start working with the RDF data. So this is pretty cool. Using 2 chunks of code with just 3 lines in each, we've downloaded zip files from the web, extracted the RDF files from within them, recompressed those files as .gz files, and then deleted the originals. We've got a nice flow going, but we can keep improving it, and that's what we'll do next time. So give this video a like if you learned something from it. Don't forget to subscribe to my channel, and I'll see you soon.